Well, hi and welcome back to my shop once again. I'm going to go to the next step on the Kalmar Electrohome receiver, and that is I'm going to test the tubes. I'm going to start in the output section and work my way back through the radio. What I noticed in this radio, what I think I noticed, is imbalanced output. So I'm going to be really looking for why one channel is coming out louder than the other. And I'm going to guess at the start here that, well, I don't have to guess, it could be a problem with one of the 4 output tubes here. So that's what I'm going to be doing. Okay, first tube is a 6BQ5, 1 of 2. So this one is 1 channel. Let's just see if it's... Usually the short light flashes on this test. I feel like it's not there. Let's see my pilot light flickering. There we go. I think my tube tester socket is failing here. There we go. Not good. Not good on the tube tester. Again, give it another moment to warm up. It's barely moving the needle. Let's give it more time to warm up. It's a big tube. Now it should be at least 3660 on the mutual conductance. Let's try it again here. Wow. Okay, so 3660. Well, I'm on the 3000 scale, so it should actually go off scale. I suspect it won't. So. Wow. That's a really weak one. I think I better write all this down. A lot of tubes. Okay, let's try the other 6BQ5. Set on the English scale, which means it's going to read replace or good. Oh my gosh, it's not even coming up. Wow. How could this thing have worked at all? Okay, I better double check things here. Just looking to make sure this is definitely a 6BQ5, no doubt about it. Okay, and the settings should be 6.3 on the heater voltage, EV. Well, these have to be correct. You can see the tube is glowing like crazy. 27930. 27930. And the bias setting is supposed to be 23, which it is. Wow. These tubes are bad. So here we go on the actual scale. Oh my gosh, we're getting 400 instead of 3600. Oh my gosh. Well, wow, I can't believe these things even work. Man. Okay, so this is the first of the driver tubes in the output section. This is a 7025 tube. It just has a number. And it's a dual triode, so it's two tubes in one. And this is the first E4. This should be reading. Okay, put this here on English. There we go. Okay, not bad. Not too bad. Let's get the actual reading here. Should be above 790. And it's at 800 on my gear. It's right at 790. So it's a pass. Here's its brother. This is the left side tube. Let's see how well this one does. So what's going on with those two output tubes being so bad? Yikes, makes me have some doubts about my tube tester. But I'm sure I've tested 7BQ5s before. Oh, here we go again. Just give it a moment. Okay, back on English. Just about exactly the same. This one's a little higher. No, it's about the same. 800. Okay, so these tubes are not testing high, but then my tube tester is very conservative. So those guys pass. Okay, so considering the condition of the two output tubes, which, when I look through the glass, I don't see any particular evidence of wear, but then that's not really a very effective way of judging the wear and tear on an output tube. Sometimes you can see a large amount of black buildup on the inside of the glass, especially with holes. You see a little hole there. Sometimes there'll be black buildup here and there. And that gives you some sense of the mileage. These ones look like they're low mileage, but they sure don't test well. I'm tempted to get my other tester out, or find a replacement tube, stick it in my existing tester. I'm going to have to probably replace these anyway, so I should go off and look for a couple of replacements. 6BQ5. Why don't let's do that before I get into the circuit itself. Okay, so I had to dig deep, but I did manage to find one. 6BQ5. The Mullard EL84 written right on it, but this one shows all that. See that black stuff? All in there. The whole top on the inside has got black stuff. There's black stuff all around here. So to me, this is a high mileage tube, and I don't know its condition at all. So I'm going to stick it in the tube tester and find out. Okay, here we go. Made in Great Britain. So this is really a test of my tester. I assume that this tube is in, okay shape, and I should get an okay reading out of it. But we'll see. And we're on English. There we go. It's not reading good at all either. Those readings are so low as to be unbelievable. What is going wrong here? 2793. 6BQ5. 27930. Oh, it's reading a little bit better. The others, let's see. The actual reading again should be 3660. So we should throw this needle right off scale. And that's reading not very good either. It's falling. Okay, we're getting about 1500, which which is as good as the gooder one in the set. You know what? I think this warrants getting another tube tester out, just to be sure here. Okay, so we'll use this tester. I think this is probably a more reliable tester. It's in a little better shape. We got the tube in, the right side tube, which was the better of the two. I'm just going to double check all the settings here. Okay, signal should be set to 4. Bias is 20H. Switches are 05176. 05176. Bottom row 0304. 0304. Sensitivity set to 30. EP, which is the plate connection here, is F. Rejection point is 1460 on the meter. Now I know you can't see the meter because of the lighting effects and contrast, and video cameras do not compete with our eyeballs for sure. But I have another camera on this that you'll be able to see the reading once I affect the average white level in the image. Okay, so let's just check for leakage. Tube. Okay, you have to trust me, the meter did not move. By the way, there's that whole clunky furnace that you hear all the time in the back of my videos. And here we go. Okay. Now what's that mean? Let me switch cameras here. I'm kind of surrounded by video cameras. So I haven't got much room to move. Put this like that. That should bring the pointer into view. Yes, it does. Okay, put the finger on the trigger here. Here we go. Okay, so on the scale, it's reading 1000 to, it's reading 1250. 1250. Okay, 1250. It's supposed to read. Supposed to read 1460. So you see, wow. 1460, 1250 versus 1480, 3600. So on my old tester, this tube is half the oomph it's supposed to have. But on this tester, it's got about 80%. Let's try the other one. Yeah, it could be some error in the settings for the other tube tester. So this is the other 6BQ5. Because, you know, the ultimate test is you put these things into your radio and does the radio work. That's the ultimate test. And this one does produce output. And these tubes look good. There's just too many indications that they should be in good shape. And there's two of them, both testing low. And they're all really, really suspicious stuff. So I think in this case, we're testing the tube tester more than anything. Check for leakage. Again, you can't see the pointer. Didn't go anywhere. What happened there? So it's not going up at all. What happened? What happened? What happened? Change the average white level here so you can see what's going on. Okay, you can see the meter there. Hit the switch. Nothing. So, hey, what's going on here? You know, this is making more sense. This tube is testing way low. This should be coming up all the way into this range. But I did notice one channel was low compared to the other. Now, let's be nervous here. One channel was not producing as much output as the other. I don't know what I just said. So I am suspicious that one tube is weak, not both. This guy has tested real bad in 2 testers. Okay, so I'm going to put my my own tube in here. Give it a moment. Leakage. Okay, hopefully you can see the meter. There we go. What's going on? I wonder if one of my switches is dirty or something like that. Careful about moving that switch. Getting a complete zero on it. Yeah, come on. This is supposed to be the part where you find out what's wrong with the tubes, not what's wrong with the tube test. Oh, there we go. Okay, I got a bad contact in both my tube testers. You know, I guess that's not to be too surprised. You keep shoving tubes in and out of the tube socket. So it's reading, it's lower than the other one, but it's much better than the other one. I can put it that way. So I'm going to put this guy into the amplifier from here forward. And the one that was in there, I think I'm going to put an X on it. I think. Okay. Here we come. Forget. Get out my marker pen. X on it. Okay, so I think I've got a barely okay and an okay tube in here. Clearly, if we put 2 brand new tubes in here, we're going to get better performance out of this amplifier. Don't think it affects the tone or anything. I think it really would just affect the volume. Now the question would be, what killed this guy? And I don't know. Who made it? General Electric? No reason to doubt it. Anyway, that seems to be the situation there with the output tube. So I think I've got a pair of fairly similar output tubes now, so when I listen, even if they're both a little low, they should be relatively the same. And you know, this is probably satisfactory. The console that this goes in is not in a disco. Isn't a room full of 100 people trying to dance, so just how much volume you really need out of it is debatable. But the cost of these tubes is not high at all. EL84s are easy to get. So I think we're on our way. And by the way, the 7025s, I only tested 1/2 of them. I didn't test the other half, mostly because I didn't think of it, but also there's really no reason to suspect them, especially if 1/2 is working. And I know the whole unit is working too. So, okay, so I think we're going to get into the what could be wrong in here. Now, this unit is full of highly reliable capacitors. Nevertheless, there are some critical ones. So the capacitor here that's blocking 80 volts from this tube plate from reaching the grid here is critical. If this guy leaks a little bit, grid goes positive, tube runs hot, and which can wear it out quickly. And then this is a bypass capacitor, and it's an electrolytic one. This capacitor has no capacity. It's just sitting there, but it's not doing its job. Too much of the signal will go through this resistor here, and it'll quiet this channel. So those two guys need to be hunted down and replaced. In fact, even if these are good, this blocking capacitor here and here, they should still be replaced at this point. There's a good chance they are good, but something killed that one too. And I could perform tests. Maybe I should. It's debatable whether I should bother. Well, let's hunt them down and see where they are anyway in the radio. Okay, so just so you can see, here's the two output tubes. So the parts we're looking for are down under here. Wow, you can see how I'm turning this. I want to keep the power transformer down low. Makes it a little more stable. It's not bad like that. So those two tubes are down here. Here they are, right there. Those two. Look at those. Look at those. What was I saying about the wonderful ceramic capacitors? Those don't look ceramic. Okay, now take a look at the circuit diagram. And very kindly they have written the pin numbers. Pin number 2. What's that? Okay, pin number 2 is the pin we're looking for. And there should be a resistor coming off it. Looks like a 1,000 ohm resistor coming off of pin number 2. I don't need my book here. By the way, somebody asked me which tube manual I'm using. You know what? Any one of these is great. These are great books. Mine is really beat up. It was given to me by a guy named Hugo Oja, who I worked with many years ago. And he just one day, he knew I was into this kind of stuff. One day he came in and goes, "Here, you might want this." I don't know if you can see it or not, but it's bound with a piece of string here. Yeah, so I certainly added my wear and tear on this book. These are wonderful books to have. Not just necessarily RCA, and not this version. This is a pretty old one. This is from the early 50s, I think. You might want to get one a little further along. But they are wonderful books. Okay, enough of that. Pin number 2. Let me do it on the close-up camera here. I think it'll be easier on me too. Looking for there's the missing pin. There. Pin number 2, going clockwise, 1, 2, is right. There's the 1,000 ohm resistor. And see, they've used that open terminal as a connection point. Look at that. It comes right to this big honkin' junk pile capacitor. Okay, these guys are deadly. They gotta go. They gotta go. Where are they? They are .047s. They look beautiful, don't they? But they gotta go. So that's easy. 2.047s there. No, we want to look for also the bypass capacitors. Well, my eyeball's drawn right to these two blue, fairly large electrolytics. How can we verify that? They are across a 150 ohm resistor. Okay, I don't see any resistor down there. I don't see any other electrolytics either. Wait a minute. I thought they were connected to this binding post, but they're not. Okay, so they go to ground here, to the chassis. The other lead comes around quickly. Bring down the close-up camera again here. So there they are. And looking at that nice black wire there. Coming around. It looks like it's connecting to that pin. That would be pin number 3. And then it has a brown-green. Yikes, is that orange? 16. What did I say on the schematic? Was it 160? I don't know what that is. Okay, we take a look here. We see it there. 150. 150. You know, I can't remember what green is. These are, look like 50 microfarads at 25 volts. Then that's got to be them anyway. I mean, so they're going right to ground here. 150. I'm drawing a blank on the right color for 5. Oh, you know, you're all shouting at me. Green is 5. Green is 5. Then that means that that orangey color. Let's take another look at it here. That orangey color is actually brown. So it'd be brown, green, brown. And it should be going to ground. Junk connected to that post. Post, almost certainly. I think I saw it there. Yeah, that's the grounded post. Yeah, there it is. So it all makes sense. Goodbye to those 4 capacitors. That'll be my next undertaking. Or should I test it? He says, wistfully. Thinking. The other side of these capacitors is a bit of a strange spot. No, it isn't. No, what am I saying? It's coming from the plate. Good thing that radio's not plugged in. Yeah, you know what? Let's test them. Let's test them just to see what the story is. So I gotta hook up a few speakers here and get some stuff ready. Okay, I think I'm all set to go here. Got my meter ready. 200 volt scale. I believe the plate on one side of these is at 80 volts. The other side, of course, should be 0. Should read 0. Speakers connected. No antenna. Who cares? Okay. I haven't operated this set. I just brought it back in the shop here. So let's keep an eye on those light bulbs during this momentous moment here. There we go. Okay, they look fine. In fact, I'll just leave it on the light bulbs for now. And we'll watch the high side of these capacitors. Whoa! Yikes, that was supposed to be 80. Isn't that interesting? Looks like it's heading its way down there. I guess that's a big part of engineering these sets, is during the turn-on, all kinds of stuff can happen. Things are pretty darn hard to anticipate. It's getting right to 80. Okie doke. Oh. Let's check the other one. Oh. Something not right there. 150 on one side, 80 on the other. Well, that might explain it right there. What is going on? Okay, let's go on the other side of these capacitors. Should see a 0 or nearly so. A little bit of voltage on that one. I'm on the restricted power too, so you expect this to be below 80, just like that. So that seems right. Something wrong there. Wow. Okay. Interesting. That's going to cause some kind of imbalance in the driver tubes too. 80 and 80. No question about that. So there's a 2200 or 220K. Yeah, I betcha one of those is not 220K anymore. Okay, so they're supposed to be coming from 230 volts. Let's take a look at that. Let's see if we can find the 220K in here. Now, don't forget it's on, Jim. Keep this in mind. The set is on. Okay, so come down here. Well, it's pretty darn easy to see. It's right there. So there's the capacitor. There's the lug. There's the 220. There's the point we need to test. There's the other 220 right there. Huh. Doesn't get any easier than that. Okay, get out of there. So it's supposed to be 230 on the other side of the 2200. Okay, so there's the 80. I do have it on restricted power. $140. Okay, hold on. Oh, I'm touching. You know what I've been doing? I've been touching the wrong lead. Touching the wrong lead. That's what's been going on. Get around to the right spot. So from here, when I look at this, this looks like the capacitor lead right here. But it's not. It's actually the other side of the 220K. The actual capacitor lead is over here. 77. 71. Still a little different. That guy's still reading 0.4. Guy reading 0.08 or something like that. Nothing dramatic going on there, but certainly this one's leaking a little bit. I'm pretty sure of that. Still quite worthwhile. Let me shut it off here before I forget. Stick my fingers in there. Still worthwhile to change out those capacitors. Especially on the power tube. Power tubes are designed for fairly heavy current flow through them, and a little bit of upset can have some dramatic effects, and that could be why the one output tube got so weak. Okay, great. I know what I'm doing. least I think I know what I'm doing.